Welcome to this higher tier predicted paper. It is just a best guess, but it is based on the topics that haven't been tested yet and the popular OCR topics. Let's do this. So question 1, we've got to write 75 as a product of prime factors. Nice, easy to get us going. We're looking for two numbers that times to 75. I know that is 25 times 3, and 3 is a prime number. We can keep going on this side. 25 is 5 times 5. Again, stop with prime numbers and circle them. And when you've got all prime numbers at the end, we can just write 75 equals 3 times 5 times 5. In this question, it doesn't say index form. If it did say index form, we'd have to write this as 3 times 5 squared. Question 2, we've got a clock chiming every 20 minutes. The minute you see something like that, you would get marks for just starting to count up in whatever it's given you. So 20, 40, 60, 80 in that case. Then we've got a light flashing every 8 minutes. So again, just counting up in whatever it's giving you to work with. And what we can see straight away is that this is a lowest common multiple question. Both the light and the clock work together every 40 minutes. The question ultimately says how many times do they work together between 8 o'clock and 12:30. So all I'm going to do is start at 8 o'clock and then start adding on 40 minutes. So the first time they work together is 8:40. We're going to add 40 minutes onto that, and that comes to 9:20. We've gone past the hour. 40 minutes onto that would be 10 o'clock. 10:40 is your next time. And we can see we're going to get the same times in terms of minutes. The next one would be 12:40. Which is no good because we want to stop at 12:30. So that's no good. I've got 1, 2, 3, 4, 5, 6 times. They work together between 8:01 and 12:30. It's saying 8:01, so you don't count the 8 o'clock time that they give you to start with. Question 3, we've got some fraction work to do. Never ever work with mixed numbers, not in a non-calculator paper. We've got 3 and 4 sevenths, so straight away I'm going to turn that to an improper fraction. 3 times 7 is 21. Add on the 4 is 25. So we've got 25 sevenths. We're going to multiply that by 7 ninths. Now you could do 25 times 7, 7 times 9, and then simplify your answer. But there's a cheeky little shortcut here. We've got 7 on top, 7 on bottom. This is just multiplication. So I can literally cancel both of those out. And you end up with 25 ninths. It does say give your answer as a mixed number in its simplest form. So we're going to count up in nines. 9, 18, 27. So 9/18 is 2 whole ones, and then I've got 7 nines left over. Be careful, always check whether that simplifies further. 7 is a prime number, so I'm finished at this point. In question 4, you can read it through. There's information provided, and the first thing we've got is acceleration. Well, that must be A. Acceleration is 4.06. I'm just going to rewrite that down as A for acceleration. There's then a time of 10.1 seconds. Well, time must be T. The annoying thing is this one here. It says initial velocity is 2.93. Something you might not know. We call that U. So the initial velocity is U. It's the only thing left really. And that's 2.93. It says hop around each value to one significant figure. Well, if we don't know what to do, we can at least get that mark there. Take these figures and just round them. So A becomes 4. T becomes 10. And U becomes 2.93 becomes 3, just rounding to one significant figure. I just got a mark for spotting this as a rounding or an estimation question and for doing the rounding. It then says we're going to use these figures to estimate the distance travelled. Well, that's just S. That's what this formula does. So we've got S equals UT plus a half AT squared. Just rewriting the formula. I'm now going to put all these figures into that. So S equals, U is 3, remember. T is now 10. Plus a half times 4, A is 4, times 10 squared. This is T. This is now just a BidMaths question. So let's just work it through. I'm going to leave everything except the indices at the end. 10 squared is 100. Then we've got some multiplication to do. 3 times 10 is 30. Leave the add alone till last. A half times 4 is a half of 4, which is 2. And 2 times 10 is... that should have been 100, sorry. 2 times 100 is 200. and you're left with 30 plus 200, which is 230. The question was just asking to show us that my mate Harper's wrong. They got 430, we've got 230. Question 5, we've got angles in a triangle in the ratio 1 to 2 to 3. Well, straight away we can add those together and see we've got 6 parts to this ratio. It's talking about triangles and angles. Angles in a triangle add up to 80. So we need to do 180 shared into those 6 parts. If you're not sure how to do this, remember this is non-calculator work. Use your bus stop. 6 into 1 is 0, remainder 1. 6 into 18 is 3. And 6 into 0 is 0. So each one of these parts is worth 30. We now just need to work out what the angles are. So I'm going to do 1 times 30 for the first angle. I'm going to do 2 times 30 for the second angle. And I'm going to do 3 odds of 30 for the third angle. And that 90 degrees there is showing that we've got a right angled triangle. Part B says the hypotenuse of the triangle is 15. So we're going to go back to his initial ratio. If the angles are in that ratio, then the sides are also in that ratio. And the hypotenuse is the longest side. So this one with the 3. And what we're saying is that is 15. And all we're doing here is creating an equivalent ratio. The triangle's actual side lengths are 5 times bigger than the ratio that's been given. So I'm just going to times everything by 5. And we get 5. 2 times 5 is 10 to 15. It says what's the shortest side? It's right there. It's 5 centimetres. Question 6, we've got some algebraic expression work to do. So we've got a rectangle with algebraic sides. This question does talk about perimeter. So I'm just going to make sure I've filled in each side. And what we're told is the perimeter is 46. Well, if you know that perimeter is these added together, and you just write that down, 4x minus 5, add x plus 3, add another 4x minus 5, and add another x plus 3. There's your perimeter in terms of algebra. That comes to 46. I just got a mark for doing nothing but writing everything equals 46. We can now simplify this. We've got 4x, 5x, 9x, 10x's all together. And then we've got minus 5, minus another 5 is minus 10. Add 3 and add 3 would come to minus 4 altogether. And that comes to 46. Now we've got an equation to solve, so I'm just going to add 4 to both sides. And we're left with 10x equals 46 add 4 is 50. Divide both sides by 10. And you're left with 1x equals 5. Now we're not quite finished because we're not trying to find x. We're trying to find the area of the rectangle. So what we need now is these two sides so we can multiply for area. We know that x is 5. This becomes 5 add 3, which is 8. This is a bit harder, but we still know x is 5. 4 times 5 is 20. And 20 take 5 is 15. The area is going to be 8 times 15. Don't let that slow you down. 8 times 10 is 80. Added to 8 times 5, which is 40. 80 add 40 is 120. Question 7, my mate Gemma's solved an inequality. People hate these, but if I put an equal sign there, you'd be able to do it no problem. And she's put her solution on a number line. We need to see if she's right. She won't be, because they never are. So let's solve the inequality and see what's happened. Like I say, if you don't like these, some teachers will say change that to an equal sign, but then you forget to change it back and lose a mark. Just treat it as if it were an equal sign. First thing we'd do is take 1 from both sides. And you end up with 3x is greater than minus 6. Then we're going to divide both sides by 3. And you're left with x is greater than minus 6 divided by 3 is minus 2. So there's the solution. Let's have a look at the number line. Well, we know that minus 2 is good. So that bit's fine. We know that this is just a greater than and not a greater than or equal to. If it was or equal to, the little line underneath, we'd colour the dot in. But we're not going to. It says x is greater than minus 2. She's done less than minus 2. So we need to do an arrow that way. This here should be enough to get full marks, but it does say explain your reasoning. Put no, she's not correct. Make sure we answer the question. And then just put something like, she's put less than, not greater than. Question 8, be careful with this one. The most common question on OCR's past papers, and it's going to catch a lot of people out. My mate Naomi's given a 10% pay decrease. Straight away, spot that. she's come down by 10%, starting at 100%, she's currently on 90%. And that is 90% of the original amount she started with, and that is the 252 that you're given. What we need to do is scale this down so we can scale it up to 100%. I'm going to start by coming down to 10%. And how are we going to do that? We're going to divide by 9. So I'm going to divide this thing by 9 as well. It will divide by 9, otherwise this wouldn't have been on a non-calculator paper. So let's just see how many 9s go into 252. 9s into 2 is 0, remainder 2. 9s into 25 is 2, remainder 7. And 9s into 72 is 8. So 10% of the original amount we now know is 28. Why did we find 10%? Now we can scale up to 100%, the thing that she started with. And all I'm going to do there is times by 10. So take your £28 times that by 10, you get 280. We've just worked out the original money that she had before it was reduced, 100%, is £280. Do not just find 10% of this number and add it back on. You're just wasting time. What we're actually asked is, well, what would she have if instead she got a 10% pay increase? Well, this is what she started with. We know that 10% of that is £28. If we add those together, we've got a 10% increase, and we're going to do 280, add 28, that comes to £308. Question 9 is actually a mistake in this question. 6/5 will not be a recurring decimal. It should be 5/6. But don't worry, it's just asking, can you turn a fraction into a decimal? So I'll stick with the original question. We've got 6/5, which is 6 divided by 5, which is how many 5s in 6? 5 into 6 is 1, remainder 1. So we're going to need a decimal, and some digits to work with. We've now got 5s into 10, which is 2. Okay, so this 6/5 is actually 1.2. And part B on this page, we've got to turn this recurring decimal into a fraction. Now there's an algebraic process that allows you to do that. So we just follow this same process every time. We're going to call this recurring decimal x and just write it out. The 6's repeat. We're then going to do 10x, which just moves the digits one place to the left. And we get that. Then we're going to do 100x, which again moves the digits one place to the left. This is just a process that you need to follow to turn a recurring decimal to a fraction. I'm going to keep going in this case and go for 1000x. And again, digits to the left, 126.66. There'd be more 6's there. Those 6's go on forever. Why am I doing this? Well, I'm looking for this here. Decimal point, all 6's. Decimal point, all 6's. That pattern after the decimal point matches perfectly when I just look at two of these things. So they're the two things that I want to pick out, and I'm going to do a subtraction now. I'm going to do 1000x, take away 100x, just those two things there. And that's the same as 126.66, take away 12.66. When we look for that repeating pattern, we did that for a reason. When I do this subtraction, 6 take 6 is gone, 6 take 6 is gone. All that repeating recurring decimal goes away. You're left with 6 take 2, which is 4. 2 take 1 is 1. And 1 take 0 is 1. Over on this side, I can actually work this out as well. 1000x take 100x is 900x. So we've got a little equation we can solve now. If 900x is 114, then single x, the original starting number, is 114 over 900. That is the answer. That is this recurring decimal as a fraction. It just says simplify, so let's just start halving top and bottom. Half of 114 would be 57. Half of 900 is 450. I know that both of these divide by 3. Okay, 3 into 57 is 19. And a 450 divided by 3 is 150. Can we go any further? Well, 19 is a prime number, so we can't go any further than that. That there is your simplest form. So the original version of this question, which I've now changed, is to write 5/6 as a recurring decimal. So I'm going to follow the same process. It's still a division, and then I'm still going to use bus stop 6's into 5 this time. 6 into 5 is 0, so we need a decimal, and some digits to work with. 6's into 5 is actually 0, remainder 5. 6's into 50 Well, 6/8 of 48, so it'll be 8 remainder 2. And then 6 is into 20, 6, 12, 18, 3 remainder 2, 6 is into 20, 3 remainder 2, 3 remainder 2. Your recurring decimal is 0.833, 3 recurring. Question 10, we've got my mate, the car mechanic. He's got a tin with 5 litres of oil. Straight away, if you've got 5 litres, multiply by 1,000 just to change it into millilitres. You'll get a mark for that. Just because the rest of the question works in millilitres, get that initial mark out of the way. Every week we use 450 millilitres of oil, and he says that after 9 weeks, he's going to have used 80%. So if we use 9 weeks at 450 millilitres per week, I'm going to do 9 lots of 450. I'm just going to set that out using a grid method and see what we get. 9 times 0 is 0, 9 times 5 is 45, 9 4s are 36, add on that 4 would be 40. So he's used 4,050 litres in the 9 weeks. We now to see what this is as a percentage. So we've got 4,050 out of the 5,000. Get a mark for writing this as a fraction, and then if we can't get the percentage, who cares? But we'll see what happens. I'm going to try and change this into a percentage. Well, straight away I can divide top and bottom by 10. So we've got 405 out of 500. I know if I divide that by 5, I'm going to get out of 100, and that there is my percentage. Anything out of 100 is your percentage. So all I need to do is figure out what this would be. So I'm just going to see how many 5s go into 405. 5s into 4 is 0 remainder 4. 5s into 40 would be 8. And 5s into 5 is 1. So this top number here is actually 81. 81 out of 100 is 81%. Just check what my mate the mechanic's saying. I will have used over 80%. Is he correct? Don't forget your mark for saying yes or no. Question 11, we're going to solve this by factorising. Now, there's a hard way and a nice way. Some of these are nice, some of these are disgusting. This one actually looks quite nice, but I'm still going to go the long way around, just in case you get a grim one. What I'm going to do is that first number multiplied by the last number. So 2 times minus 33 is minus 66. What I'm now looking for is 2 numbers that add up to the middle thing, but multiply to that thing there. And those 2 numbers are 3 and minus 22. 3 times minus 22 is minus 66, and 3 add minus 22 is the minus 19. What I'm going to do now is use these numbers to rewrite this quadratic. So we keep the 2x squared. The 3 and the minus 22 go in the middle, plus 3x, minus 22x, and then we keep that minus 33 on the end. Now what I'm going to do now is just split this in half, factorise this left-hand side. So what goes into 2x squared and 3x? The only thing is x. X times something is 2x squared. X times 2x is 2x squared. X times something is 3x. X times 3 is 3x. Factorise this left-hand side. What goes into minus 22 and minus 33? The answer is minus 11. There's your common factor. Minus 11 times 2x is minus 22x. And minus 11 times positive 3 is minus 33. That's good. These 2 brackets match. So that's my first bracket. And then my second bracket, this and this goes in. Now don't forget that this was an equation, so we should really have had equals 0 all the way down here. We've got an easy solution straight off. If x minus 11 is one of your brackets, then one of your x's is 11, just the opposite of that. The harder one on this side, we're just going to form another little equation that says 2x plus 3 equals 0. Take 3 from both sides, you get 2x equals minus 3. And then divide both sides by 2, you get x equals minus 3 over 2. They're your 2 solutions. Question 12, we've got some transformation work to do. So first thing, we're going to draw the image of triangle A after a reflection in the line y equals minus 1. Be careful with this. We're looking for y, which is here. We're then going up and down the y-axis till we get to minus 1. And that is the line that you're reflecting in. It goes the opposite direction to the y-axis. So the triangle we're reflecting is A. what I'm going to do is count to that line 1, 2 full squares, and then 1, 2 full squares on the other side. Same for every point, 1, 2 full squares, 1, 2 full squares. That's the bottom of my triangle. This one here will be 1, 2, 3, 4, 5 full squares, 1, 2, 3, 4, 5 full squares. And what we get is the reflected triangle. Part B says, describe fully the transformation that maps A onto B. So how does A get to B? Well, I know it's getting smaller. You will get a mark just for writing the word enlargement. Even though it's getting smaller, A to B, we call it an enlargement. If we look for how much smaller it's got, that base is 2 across, that base is 1 across. That gives us a scale factor of a half. These triangle sides are half as big as they were, so that's why my scale factor is a half. The hardest bit of this to find is something called the centre, or the centre of enlargement, and it's where this triangle is like growing from or shrinking to. If you connect any matching points up and keep going, so I connected those 2 tops, I'm now going to connect these 2 bottoms. And if I did the same with this bottom here, bish bash bosh, you'll see that all these lines cross over at a certain point. That there is your centre. And we need the coordinate of that for this final mark. So to get that point across to 5 and up to 7, the centre is the coordinate 5, 7. This final one's a bit tricky. It says, complete the statement. We're going to rotate 180 degrees around 0, 0. Well, imagine triangle A span 180 degrees around 0, 0. It would look like that. It's done a full half turn around 0, 0. Now, what we're trying to describe is that as an enlargement, and it's clearly not got any bigger. So if we're saying that's an enlargement, but it's not got any bigger, we can say the scale factor is not 1, it's actually -1. Why is it -1? Well, I'll do what I did with the red lines. If I connect matching points, you will see that they all cross over through the centre. But what we've done, imagine, is like inverted this triangle. It's come through the centre and flipped out on the other side. And in order to do that, you need a scale factor of -1. We've got the centre already. The centre is 0, 0. Bit of a weird one, that, but it explains a little bit about the negative scale factor as an enlargement. Question 13, we've got some construction work to do. It might be a bit rough, this, because I am doing it on a device without a compass. You need a compass in order to do this. It says, construct the bisector of angle BAC. So from B to A and then on to C. This here is the angle that I'm going to bisect. You grab your compass and put it there. What I'm going to do is draw an arc, part of a circle, around A. You then get your compass and place it here. And you're going to draw an arc right there, around that point. Keep your compass the same width, but put it there now. And draw an arc around that. And if you've got those arcs crossing over, you can connect to your original angle and you've bisected the angle. Part B says construct the perpendicular bisector of AC. Well, AC is this line here. Again, we're going to use a compass. Put your compass point there and just draw this nice big arc around it. What you must do now is, again, keep your compass the same width, but place the point on this side and draw the same arc around that. And again, we've got these crossover lines. Mine's a bit rough, but if you connect those together, then you've bisected that line. Mine's a bit dodgy, but we've effectively cut that green line in half. Final part, part C, it says shade the region inside the triangle that is nearer to AC than to AB. So nearer to AC, well, AC is this bottom line, AB is this side line. Nearer to AC than AB will be underneath my initial red line. That's closer to AC than it is to AB. Then it says nearer to A than to C. Well, A is here, C is over here. I'm now looking at my green line. Nearer to A than C is this zone here. So I shouldn't have actually shaded in anything on that side because I want both conditions met. Question 14, an algebraic proof to do, and this one talks about consecutive square numbers. So we need to know some definitions first. your square numbers look like this. The first one is x squared. The second one is x plus 1 squared. The next one after that would be x plus 2 squared. And I could keep going, but I don't actually need this one. I just need 2 consecutive square numbers. And difference is a subtraction. So what I'm going to do is start with the bigger one, which I think will be x plus 1 squared, and take away x squared. From this point, it's just algebra. These are double brackets. X plus 1 times x plus 1 is x plus 1 all squared. So that's a double bracket. I'm going to take away the x squared on the end. Expand these double brackets. X times x is x squared. X times 1 is 1x. 1 times x is another 1x. And then 1 times 1 is 1. Use your loops or your grid to expand that double bracket if you didn't see what I did there. Then take away the x squared that's sat on the end. Now we're going to tidy this up. We've got x squared, take away x squared, so that's gone away. 1x add 1x is 2x's, and 2x add 1 is what we finish with. It says show that this is always odd. Well, 2x is another definition you need for proofs. That's your even numbers. And if 2x is even, then 2x add 1 is just an even number with 1 more added on. And that's an odd number. Question 15, my mate Carol's done some negative fractional indices work. Okay, so we need to work this through step by step. I'm just going to do the right answer, and that'll explain what Carol's done wrong. First things first, we'll deal with the half, and it's not half in 64, it's 64 to the power of a half, and that there is the square root of 64. When you're raising to the power of a half, you're square rooting. Well, 8 eighths is 64, so the square root of 64 is 8. Then we'll deal with the negative. It was actually negative a half, so we'll do 8, my answer now, not to negative a half, just to negative 1, just to get this negative in there. And 8 to the negative 1 is 1 over 8. So that there is the correct answer that my pal Carol should have got. What she got is 1/32. From 64 to 32, she just halved, didn't she? So she halved 64 rather than square root 64. So I'm just going to write that down. Just one more time, raising to the power of a half is square rooting, not halving. Question 16, we've got a cylinder and a cone and a load of information about what's going on. If you don't know what to do on these questions, then just do whatever you can do. There is a circle, and this question talks about volume. So I might work out the volume of this cylinder. Well, first thing I can do is work out the area of a circle, and that's just going to be pi r squared. The radius is 2, so I'm going to do pi times 2 squared. 2 squared is 4. That is 4 pi. I might not know where to go from that, but I've got marks for starting this problem. The length of this cylinder is 9, so if I now just times by 9, I get the volume of the cylinder, which is 9 times 4 pi, and that is 36 pi. Once again, I've not even read the question, but I've just spotted a cylinder, a circle, multiplied by 9. I've got plenty of marks for not even starting. It says for the cone, the radius and the height are in the ratio 1 to 4, and that's a key bit of information there. It's saying the height of the cone is 4 times bigger than the radius of the cone. So what I'm going to do, if this is 4 times bigger than that, I'm going to change this to just 4r. And what that does is gets rid of the h term that I might not need. What we can do is actually work on the question now. It says the volumes of these things are equal. We get a formula for the volume of the cone, and what we're actually trying to work out is r. So if those things are equal, then I can write them equal to each other. So the 36 pi that I worked out to start with is equal to this formula that I've got for the cone, and it's pi times r squared. And remember, h we changed to 4r, and I've got rid of that h term. It's just an extra thing that I don't need. I'm going to tidy this up a little bit. We get 36 pi equals r squared times 4r will be 4r cubed. So we get a third pi times 4r cubed. I just multiplied those r's together. We've got pi on both sides, so what we can effectively do is divide both sides by pi, which just gets rid of those. I also don't like this 4 here. I've noticed that I can actually divide both sides by 4, and that'll get rid of that 4 there. So I'm going to do that and just rewrite this. 36 divided by 4 is 9. And on this side, the 4 divided by 4 is gone. I get a third r cubed. Looking much nicer. A third is just dividing by 3, so let's undo that. And times by 3. 9 threes are 27, and that is now your radius cubed. And if your radius cubed is 27, your radius is the cube root of 27, which is 3. So in question 17, we've got two triangles drawn together. This is screaming Pythagoras and trigonometry. I know Pythagoras ring paper 1, but I've included this to show that trig can be in the non-calculator paper, and also a diagram can come like this in paper 6 if you're looking at sine rule and cosine rule. So let's have a look. If you've ever got two triangles drawn together, chances are you'll need to work out the side connecting them. And I think the only triangle I can work on to start with is this one, because I've got two things and I want to find a third. So I'm going to sketch that triangle out. We know the angle is 60. We know that that is a half, and I'm going to try and work this out. This is trigonometry all day long. That's the opposite. Longest side is the hypotenuse, meaning that's the adjacent. I'm looking for the adjacent. I've got the hypotenuse, so that's what's involved. I'll just write out so ka toa, and adjacent hypotenuse is your cosine. So let's write that out fully. Cos theta equals adjacent over hypotenuse. If we now start to substitute things into this, my angle theta is 60. My adjacent is the thing I'm looking for, and the hypotenuse is 12. And then there's a one-step rearrangement. Times both sides by 12, you get 12 cos 60 equals question mark. This is non-calculator. If you're ever unsure about this, just guess. If you don't know your exact trig values, just guess, and usually it's a half, and cos 60 is a half. So I'm going to do 12 times a half, which is a half of 12, which is just 6. I found this side that connects my two triangles. It's 6. The actual question says work out the length of AB, which is this length. So now I'm working on this triangle on the left. I've not left much space, but I guess I could work this at the top. I know that this is 6. I'm trying to find this. This is Pythagoras all day long, so shorter sides are A and B. Longest side is C. So now I'm just going to write down Pythagoras' theorem. A squared plus B squared equals C squared. Substituting in, A is my 6 that I just found. B is unknown. And C is 10. Work these out. 6 squared is 36. B squared we still don't know. And 10 squared is 100. Remember, if you're looking for a shorter side, this becomes a subtraction. So B squared is 100. Take 36, which is 64. And that's B squared. So B will be the square root of 64, which is 8. Question 18, quite an easy one if you just look at your types of graph as you're walking into your exam. This says sketch the graph of y equals sine x. Well, y equals sine of x hits key points at these 4 angles. So at 90 degrees, we're up at 1. At 180, we're back down to 0. 270, we're at -1. And 360, back to 0. We've got this sine wave function. That's a bit rubbish, but you kind of understand the idea, I'm sure. Part B talks about the graph of y equals cos of x minus 30. So I'm not going to start with that. I'm going to start with y equals cos x, which is similar to the one we've just drawn, but shifted slightly. So y equals cos x looks like this. So we start up here this time, through there. So that there is y equals cos x. I ought to label y equals sine x as well. Now when you're looking at y equals cos of x minus 30, what that's going to do is shove cos of x 30 degrees that way. It's opposite to what you might think. You don't go 30 degrees to the left. That negative there in the brackets pushes your graph 30 degrees to the right. So if we look at cos x, we're talking about where we cross the x-axis there, 90 degrees, and there, 270 degrees, but that, remember, is cos x. I want to add 30 onto that to show that I'm moving 30 to the right. And 90 degrees add 30 degrees is going to be 120 degrees. 270 add 30 degrees will be 300 degrees. Question 19, my mate Ella's drawn a probability tree. She's had an absolute stinker here. Just check it through. We're just looking for the errors that she's made. So it says on Monday, the probability of rain is 0.55. So there's Monday, there's rain. That's sound. What I can do straight away is check these two. These always need to add up to 1. And I'm just going to check that. 0.55 add 0.35. That only comes to 0.9. So I'm just going to write that down as her first error. So it's this figure what she's got wrong. That should be 0.45. It's another way of writing that. Let's have a look what else she might have done. It says probability that it will rain on Tuesday is 0.25. Well, there's Tuesday. There's rain. She's got 0.75. She's got these branches the wrong way round. So again, I'm just going to write that. And then finally, what else might she done wrong? Well, when you ever see a tree diagram like this, usually we've got a set of branches down here. We don't always need them, but we do in this case. If we're talking about the weather, we want to know what's going to happen on Tuesday, even when it doesn't rain on Monday. So we've got missing branches. So again, I'll just write that down. And there are your 3 errors on the probability tree. Just a quick notice, if we were actually working out some probabilities, let's say probability of rain, we'd just take these things and multiply them together. Okay, so the probability of rain would be 0.55 multiplied by 0.75. I'm not going to do that for you, but I just thought I'd drop that in there while we're looking at this as part of this revision. Question 20, we've got some graph work to do. It's actually shading regions and inequalities, but let's have a look. We've got the graph of y equals -2, and then look down here. We've almost got a matching inequality. Y is greater than or equal to -2. So we've got 2 things that match there. Then we've got y equals x, and we've got an inequality very similar to that. Y is less than or equal to x. And then we've got just this thing, but no matching graph. So this must be the thing that I'm looking to draw. I need to draw x equals 4. So let's draw that in. There's my x. There's 4. There is x equals 4. And I'm drawing it as a dashed line. And I'll explain why in a second. So I've drawn the third line that it asked me for later in the question. Now what we've got to do is shade a region, or be careful. More often than not, it's this triangle in the middle, but OCR can sometimes be a little bit naughty and give you like a region out here or down here, something like that's not obvious. So let's actually check that this middle zone satisfies these inequalities. I'll look at this one first. Where is x less than 4? Well, if that's x equals 4, x is less than 4, is everything that way. So I've done that bit. Let's have a look at this one. Y is less than or equal to x. Well, if this is y equals x, let's pick a coordinate just underneath it. That looks sensible. This is the coordinate 2, 1. And I just want to check, is y less than or equal to x? There's y. Is that less than or equal to x? Yes. So that coordinate matches this inequality. And that means any coordinate underneath that line will match this inequality. Let's have a look at the third one. It says y is greater than or equal to -2. Well, if this is y equals -2, bigger than -2 is actually going upwards, isn't it? So can you see all my arrows are pointing into one zone, which is this triangle in the middle that we're going to call R. Just be very careful on OCR. If it's a 5 marker in particular, sometimes they'll shade this region outside or something like that, just to make sure you are testing that each coordinate matches the inequalities that you're given. Quick note on why I did a dashed line here and not a solid line. It's right there, look, it says x is less than 4. If that was x is less than or equal to 4, then I'd have done a solid line. The less than means not equal to, so I can't have a solid line, I just need the dashed line. Question 21, we've got an arcs and sectors question, very much like the cylinder and cone question that we had earlier. You don't know which version is going to come up. So we've told that the area of this sector is 40 pi. We know the radius. What we don't know is this angle theta. So that's where I'm going to start, okay? The area of a sector is the angle that should be in the middle out of 360, always 360 because that's angles around a point or in a full circle. So theta over 360 multiplied by pi multiplied by the radius square is the area of this thing. but we're told that the area is 40 pi. So that's where we're going to start. We can straight away cancel pi on both sides. We can see there's a times pi and there's a times pi. So if I divide both sides by pi, that goes away. We know my radius is 10, so I can actually fill that bit in. So theta out of 360 times 10 squared is 100 is 40. And what I can do now is start to solve this in order to work out the missing angle theta. I can actually rearrange this before I do to make it a bit nice for myself. If I'm dividing by 360 and timesing by 100, I can rewrite this with theta on its own, still timesing by 100 and dividing by 360 is still the 40. All I did is combine these two things together, and that allows me to then simplify this fraction, which is 5 over 18. So I'm just going to rewrite once again. Theta times 5/18 equals 40. I've got to sort this out. In order to solve this, I need to times by 18 and divide by 5. So the first thing I'm going to do is divide both sides by 5. And 40 divided by 5 is 8. And then I need to times by 18. So I'm just going to do that up here. 8 times 18. 8 eights are 64. And 8 ones are 8. Add the 6 is 14. So what we get after all that is theta is 144. If you didn't see what I did there, I times both sides by 18 and divided both sides by 5, but I just did it in the other order. I divided by 5 first to get 8, and then times by 18, and 8 18s is 144, and that gives me the missing angle theta. So now I know this is 144. What we're actually looking to do is work out the perimeter of the sector, and the perimeter is all the way around, including this bit. So I'm going to use a similar formula to what I use down here, but it's going to be for the circumference. So I'm going to do theta over 360 times pi times diameter. This is for the circumference of a circle. So let's work this out. We've got 144 out of 360 times pi. If my radius is 10, my diameter will be 20. And that equals the circumference. Now I've got all that to tidy up as well. No real nice way to do this other than start to maybe simplify stuff. I'm going to times by 20 and divide by 360. Well, I can knock a 0 off both of those to start with. So effectively dividing by 10 top and bottom. I've still got the 2, so I'm going to do 2 times 144, which is 288 over 36. And then that is still multiplied by pi. I'm just tidying all this up as I go. 288 divided by 36. It's getting a bit messy, this, I do apologise, is the same as 144 over 18. Again, half in top and bottom. That's the same as 72 over 9. And 72 divided by 9 is 8. So all of that simplifies down to 8 pi. Now when I said that was circumference, it's not actually circumference, it's this arc length here. So I've actually worked out that bit is 8 pi. Don't forget we're looking for full perimeter, so I need to add on this radius and I need to add on this radius. So the perimeter P is going to be my 8 pi. Add 10 is add 20. Question 22, an algebraic fraction to simplify. This is just a pair of quadratics. So I'm going to start with the top one. It's a bit of a weird one that, but I'm trying to factorise this. The only common factor of 2x squared and minus 50 is 2. So I'm going to take out a factor of 2 and then work out this bracket. 2 times something is 2x squared. 2 times x squared is 2x squared. And 2 times something is minus 50. 2 times minus 25 is minus 50. This is a special case. This here is now the difference of two squares. Look up difference of two squares if you don't recognise this. We've got a square number, and a subtraction. That there will factorise into double brackets. And x goes in both brackets. And this square number, the square root of that is 5. And we put a 5 in each bracket, plus 5, minus 5. Like I say, look up difference of two squares if you don't recognise that. There's only a certain amount of questions they could give. For example, that could be 100. And then you'd have a 10 and a 10 in this bracket. That could be 36. You'd have a 6 and a 6 in this bracket. So there's your top line factorised. Your bottom line is a bog standard quadratic that's just going to factorise into two brackets. x in both brackets, and then we want something that adds to 7, times us to 10. That is 2 and 5. Just rewrite this all as it should be. On the top of my fraction, we've got two lots of x plus 5 times x minus 5. On the bottom of my fraction, we've got x plus 2 times x plus 5. Write that as an actual fraction. You'll always find when simplifying these that there's a bracket that matches top and bottom, so we can cross those out, and you get two lots of x minus 5 over x plus 2. No need for the brackets, but it doesn't do any harm. Don't bother expanding the top back out, that's fine exactly as it is. Question 23, we've got a sequence. We're told it's a quadratic sequence, so it's going to be one of the more difficult ones. We've just got to follow this process to find the nth term of a quadratic sequence. First step, figure out what's happening between terms. So from 2 to 15 is add 13. From 15 to 34 is add 19. And from 34 to 59 is add 25. We're now going to figure out what's happening between these terms. 13 to 19 is plus 6. 19 to 25 is plus 6. And I'm happy because that matches. The minute I've got this second difference, we must remember to half it and put in front of n squared. We just got a mark for just working through that process and writing 3n squared. Now we need to know n squared is your square numbers 1, 4, 9, 16. So 3n squared is those tripled. So 1 tripled, or 1 times 3 is 3. 4 tripled, 4 times 3 is 12. 9 times 3 is 27. I'm going to stop there. There's no need to go any further. Second to last step, we've got to do a subtraction now. So I'm going to start with the question and take away this thing I just worked out. 2 take 3 is minus 1. Question, take away the thing I just worked out. 15 take 12 is 3. Question, take away the thing I worked out. 34 take 27 is 7. Now there's only one thing left to do, which is to work out the nth term of this thing. That is going up in 4s. So I'm going to write 4n. How do we get from 4n, the 4 times table, to this thing? Well, the 4 times table is 4, 8, 12. This is 1, 3, 7. This thing here is the 4 times table, take away 5. So I'm just going to summarise all that together. We've got 3n squared plus 4n, take away 5. That is the nth term expression for my quadratic sequence. We do need to just finish the question. We've got it in the right form. Just make sure we put the right numbers in the right place. A is 3, B is 4, and C is, I'm just going to write it here, minus 5. Final question on this paper, we've got some more quadratic work to do. We've got x squared plus 4x minus 16, and we're looking to write it in that form, which is completed square form. If you see that, it's saying complete the square. How do you do that? You've got a single bracket squared. X goes into that bracket. This number here, this 4, we always half it and put that in the bracket as well. And then this 2 that we just created, we're going to square it and subtract it. So 2 squared is 4. I'm going to take 4. This minus 16 on the end is still there. We can't ignore that. And then we've just got to tidy up that end bit. We've got x plus 2 all squared minus 4 minus 16 is minus 20. There is your final answer. That is completed square form. Part 2 says, solve the equation x squared plus 4x minus 16. There should actually be an equals 0 on there. So in order to solve that, we're going to use the completed square form that we've got already. We've got x plus 2 all squared minus 20 equals 0. Can't solve it unless it's actually an equation. How do we solve this? Well, same as any other equation, just same things to both sides. Add 20 to both sides and you've got x plus 2 squared equals 20. Square root both sides, you get x plus 2 equals the square root of 20. Now there is a positive and a negative square root of 20. So when we're solving like this, we need to just make sure we've got the positive and negative answer. We're now going to take 2 from both sides and we're left with x equals minus 2 plus or minus the square root of 20. This plus or minus gives us two options. We've got minus 2 plus root 20, so that's my first answer. And then we've got minus 2 minus root 20, so there's my second answer. And there are two solutions to the quadratic. Final part of this question, what we're trying to do is sketch this graph. Well, we've already completed the square for this thing. We've got x plus 2 all squared minus 20. So there's the completed square form. That actually gives us something called the turning point, which is a coordinate on this graph. The turning point is just a single coordinate. That 2 in the bracket becomes minus 2. We just reverse the sign of the thing in the bracket, and we keep that minus 20. And that's all we need to know. We're going to try and plot that point, so it'll be across to minus 2, down to minus 20. It doesn't have to be perfect. We just have to show we know where that point is. Because this is a quadratic and it's a positive quadratic, we're going to get this U shape. So what we're going to do is come down like this. We're going to hit the turning point, and then we're going to come back up there. Just a few notes. This minus 16 will be your y-intercept if you ever ask for it. And if you ever want these 2 points, then what you need to do is take your original quadratic, factorize it into double brackets. Now this quadratic doesn't factorize very nicely, but if we got x plus 2 and x minus 4, then we could work out those points as minus 2 and positive 4. Remember, just reversing the sign of whatever's in your brackets. This question is only 3 marks, so it's not actually asking for these points. But if it was, factorize into double brackets and then just reverse the sign of what's in the brackets. Guys, this is just a predicted paper. I'm not saying that every one of these questions is going to be on the second OCR paper. I would be very surprised if at least half of these skills weren't on there. Make sure you're comfortable with as much content as possible. Ignore anything that definitely needs a calculator to be answered, because that's unlikely to come up. Good luck.